In this presentation, I will introduce uninformative priors. Uninformative priors assume that all possible outcome values are equally likely. Such priors make sense when we have no information about the distribution of outcome variables. There are two types of uninformative priors. Uniform priors assume that all outcome values have exactly the same probability to occur. Locally uniform priors, in contrast, are centered on a most likely parameter value, but assume very large variances. For example, a locally uniform normal distribution would have extremely thick tails. Currently, uninformative priors are frequently used and the default in the available statistical software. Limitations of uninformative priors. An uninformative prior may be our best assumption when we know very little to nothing about the distribution of effects. But more often than not, we have information about the outcome distributions we expect. For example, previous studies may suggest that some outcome values are more plausible and more likely to occur. Uninformative priors ignore such information. In this context, it is important to recognize that by using uninformative priors, researchers make strong assumptions about the distribution, and these strong assumptions will affect results. If these assumptions are incorrect, the quality of the posterior distribution will suffer. In these cases, using trustworthy available information and informative priors promises to improve the quality of posterior distributions. The use of uninformative priors as defaults encourages ritualized applications and discourages researchers to consider potentially more useful informative priors. When should researchers use uninformative priors? Uninformative priors are our best guess when we really know very little to nothing about the distribution of effects. In these cases, researchers should not only use uninformative priors, they should also explicitly justify their use based on the absence of prior evidence or their distrust of the available prior evidence. In addition, uninformative priors can play another important role in the context of Bayesian robustness tests. Here they can serve as baseline models to identify the impact of informative priors on the estimated posterior distributions. So in conclusion, uninformative priors should be priors of last resort. As the main prior in a Bayesian analysis, they should be used only when meaningful informative priors cannot be identified. If you have any related questions, please do not hesitate to contact me via email.